So, you now have some technical background of what happens under the hood with Semgrep. And I've given you some tips on how to debug negative patterns. But there's one more thing I want to mention. This is a mistake that I commonly see often in the community Slack or during my rule workshops. And it is the difference between pattern not and pattern not inside. I have an example function where I first perform the sum of a plus b, and then I compute the sum for a plus b plus c. And if I use pattern a plus b and click run, then you'll see that I have two findings. This is because our abstract syntax tree for a plus b is also in the abstract syntax tree for a plus b plus c. And so we have findings in both of these lines of code. Now if I add a pattern not for a plus b plus c, you might think that we will remove the finding on line 3. However, this is not the case. I have drawn the abstract syntax trees for a plus b and the one for a plus b plus c. They look like this. If we have a pattern and test code, both the pattern and the test code will be parsed to abstract syntax trees, and these trees would be compared. So if our pattern is a plus b and our test code is a plus b plus c, you'll see that this abstract syntax tree is part of this one, and so there will be a finding. So if we have our test code from before, where we do both sums, and we have the pattern a plus b, we will have two findings. And these are saved as a set of ranges, as I've said before, and I've indicated those with these green lines. Now, if we have the pattern a plus b plus c, we'll again have a finding, except only one finding this time, and this will have a slightly larger range, as I've indicated with this orange line. Now, if we use this as a pattern and a pattern not, we'll do some set logic. We have two findings with these ranges, and we're trying to remove a third finding. This is not the exact same range, and so with the set logic, the original finding, the original two findings, will not be removed. However, if we were to use pattern not inside, you'll see that this finding, a plus b, is actually inside the range for a plus b plus c. And so then this finding will be removed. And I'll demonstrate that we can use pattern not inside instead to remove it. Another useful way to only match this and not this would be to use pattern s equals a plus b. And you'll see that we do not have a finding on line 3. Because the abstract syntax trees for s equals a plus b and s equals a plus b plus c are slightly different. The outer shape is no longer a summation, but it is now an assignment, as you can see here. S equals, and then we have the sum of a plus b. In here we have s equals the sum of something with c, and then the sum of this something is again a sum, a plus b. And as you can see, this abstract syntax tree is no longer a subtree of this one. So while I don't expect you to parse code into abstract syntax trees in your mind, it is useful to think about the shape of your code. Am I looking at an addition or a variable assignment or maybe an entire function declaration? And to think about, is the pattern that I'm trying to subtract, is the negative pattern that I'm using, this same shape, or is it a subtree of what it could be?